So, welcome you all for this video. The course name is Wireless and Cellular Communication, bearing the subject code as 18EC81. So, today I am going to explain about module 2, that is GSM and TDMA technology. Me, Jyoti H, Assistant Professor, Department of ECE, SJBIT. So, under this module, so let us learn first as system GSM system overview. So, which is been that is the digital system which is been evolved due to the desire by European countries. In the year of 1982, the frequency bands are 890 to 915 megahertz and 935 to 960 megahertz frequency range. So, the international was a force assembled during the 1982. So, the first it was in 1987 GSM, which is formally adopted by the European Commission. So, the first generation along that is analog cellular systems were designed for basic voice services. The second generation GSM cellular system was designed to be an integrated wireless voice data service network, which is offered several other services. One is the tele services, other one is bearer services. So, the naming is only suggesting tele is nothing but the voice communication, bearer is nothing but the data service. So, this is the block diagram which is depicting of the GSM services. So, the end user going to be a first end user and the last one is the end user, under that the GSM network and the transmission networks. So, there are two services come into picture, that is the GSM bearer services, other one is the GSM tele services. So, under the tele services, that is tele services provide a standard voice communication between end users and the additional communication between the two end user application according to some standard protocol. That is, one is the offered services are mobile telephony and emergency calling comes under tele services. Next is the bearer services provide user with the ability to transfer data between the user network interface, include the various data services for information transfer between the GSM and the other networks like PSTN, IDN, etc. with the data rate of 300 to 9600 bps. So, next is the short message services is up to 160 characters alphanumeric data transmission to or from the mobile terminal voice mailbox. So, next is the supplementary services other than bearing, call bearing and the tele services. Bearer services for data and the tele services for voice. Another to establish the connection to enhance those services, another supplementary services are required. So, the supplementary services are that are enhance or support the tele service provided by the network, that is a call related service. Those are call waiting, that is the notification of an incoming call while the handset, the call hold, put a caller on hold to take another call. Call bearing is nothing but all calls and outgoing calls or incoming calls. So, call forwarding, calls can be sent to various numbers defined by the user, or the multi-party call conferencing, that is going to link up the multiple users together. So, the tele service provide the standard voice communication between the end users and the additional communication between the two end users application according to some standard protocol. One is the bearer services provide the user the ability to transmit the data between users. So, the GSM services are classified into three phases, phase 1, phase 2 and phase 2 plus. Under phase 1, that is provided GSM services and the bearer services. Phase 2 provided the supplementary services with the phase 1. Phase 2 plus, which is focuses on the additional of high speed packet data services. So, next one is under phase 1, the GSM services are offered as telephony, emergency call, short message service, video text access, teletext, fax, etc. So, additional details are full rate at 13 kilobits per second voice. So, which is 112 is the GSM wide energy number is been identified, that is the point to point communication come into picture. So, the next is the GSM bearer service, asynchronous data, synchronous packet data and others. So, you know the synchronous data and asynchronous. Synchronous is going to be a burst of data, asynchronous is going to, you can send a character by character data, which is of the data rate is 300 to 9600 bps, that is transparent and non-transparent. So, 2400 to 600 bps, that is transparent data. So when we go for non-transparent, when it is for the unacknowledged process, we go for the non-transparent data. So supplementary services are call forwarding and call bearing. That is all calls when the subscriber is not available, outgoing calls with the specification. Next is the subcategory services. So subcategory is nothing but GSM teleservices, what is half rate speech coder, enhanced full rate, half rate speech coder. Next one is the enhanced full rate. So this is the optional implementation, nothing but in the half rate, that is the one half the is going to be utilized for the call, that's rest of the half is going to be utilized for the data service. So supplementary services, as I mentioned earlier also, that is the calling line indication, connected line identification, call waiting, call hold, multidisciplinary communication, closed user group, advice of charge, and the operator determined call bearing. First one is the presentation or restrictions displaying the caller's ID, presentation and restrictions of displaying the caller ID, incoming call during the current conservation, and then conversation, and the second one is the put current call on hold to answer another, and next one is the that is the advice of charges up to 5 ongoing calls can be included in one conversation. So the restrictions of certain features from the individual subscriber by the operator. So next is the GSM cellular system is the air interface consisting of a channel that have frequency separation of 200 kilohertz. So GSM has 3 bands, and GSM 900 which is have 124 carriers, SM is GSM 1800 is 374 carrier frequencies, GSM 1900 is going to have the 299 carrier frequencies. Each of the carriers can be shared by either users. So the total number of channels for each user is going to be 124 into 8 is 992 channels for GSM 900. 324 into 8 is going to be 2902 channels for GSM 1800. 299 into 8 is 2392 channels for GSM the 1900. So the extended GSM services are 900 GSM 900 and the railway GSM 900 and the GSM 1800, GSM 1900, GSM 450 and GSM 480. So what are the frequency allocation? There are A to F band of frequencies are allocated. So A and B bands are going to be a MTA, and that is for mobile stations, and the C, D, E and F bands are going to be a base stations. So here you are able to see the A, B and C channel is going to bandwidth is 1,850 megahertz. D, E, F channel bandwidth is going to be 5 megahertz. So sorry, each A, B, C bandwidth is going to be 15 megahertz. It is getting started with the 1850 megahertz and uplink frequency, and is going to be end to the 1910 megahertz. So A, B and C channel is of 15 megahertz, D, E and F channels are 5 megahertz. So 1910 to now 1930 megahertz channels are going to be unlicensed, and 1930 megahertz to 1990 megahertz channel are going to be licensed. So these are the frequency are considered as the downlink frequencies. So used for the personal communication services, B road range for voice and data telecommunication services that enable the people to communicate via the two-way radio phones based exclusively on digital technologies such as CDMA and GSM. So you are able to see the time slot, that is the since the GSMA mobile technology will use the TDMA as the modulation technique. So each of the time slot is going to be divided as 8 time slots, and each of the time slot going to be considered as a physical channel. So here you are able to see the GSM bands uplink frequency and the downlink frequency. How uplink frequency is going to be calculated? So since the bandwidth is fixed, that is the 890 plus 0.2 into n, where what is n, where n is varies as mentioned as from 1 to 124, and it is referred as the absolute radio frequency channel number. Downlink is going to be calculated as the uplink frequency plus 45 megahertz is the guard band. So 45 megahertz is referred as a duplex spacing which is the difference between uplink and the downlink frequency channels. So, next is going to be a GSM network system architecture. So, where you are able to see the architectural diagram of GSM, which is going to have that is visitor location register, home location register, and PSTN, and being connected, and MSC, VLR, and SMS services. So, you are able to see three major services here. That is a network switching systems, major 5 blocks. One is the mobile station, next one is the base station system, third one is a network switching system, and the fourth one is the administrative control system. So, the mobile station, which is an initiator, based on the initiation the base system is going to be activated. Based on this base system station system activation, the network switching system is going to be activated. Based on that, the administration is going to be, control system is going to be activated. So, you are able to see under the base station system, there is an antenna system, radio base station, and the base controller base station controller is going to be come into picture. Once the call been initiated by the mobile station, been connected to the nearest BTS, that is the base station transceiver antenna. From that it is been connected to the radio base station, and from that it is been connected to the base station controller, which is going to forward this call to the mobile switching center by using the FNR. So, the mobile station is a device that provides the radio link between the GSM subscriber and the wireless mobile network. Mobile equipment ME, and the GSM also makes use of the subscriber identity module, that is the SIM, and the SIM card that when inserted into the mobile station makes it functional. So, base station system is, as I mentioned, is going to have the BTS and the base station controller. Network switching system is going to have the mobile switching center, home location register, visitor location register, authentication center, and the equipment identity. So, the mobile station is made up of two entities. One is the mobile equipment, that is a SIM, and the PDN. That is the PDN description for network that provides a data service. Packet switching is mode of data transmission in which a message is broken into number of parts that are sent independently over whatever the route is optimum for each packet, and the reassembled at the destination. So, the internet is the packet data network. So, the mobile station can make calls without SIM card. Mobile equipment is the portable vehicle mounted handheld device. So, uniquely identified by IMEI number, that is International Mobile Equipment Identity, voice and data transmission, monitoring power and the signal quality by surrounding the cells for optimum handover, and the power level is going to be a 0.8 watts to 20 watts, 160 characters as the long SMS. So, what is PSTN? So, PSTN is nothing but which is going to carry the voice signal calls from the your phone to the other switching networks. So, that is the PSTN has traditionally been costly and challenging. So, which is been adopted the protocol as a VoIP, that is voice over the internet, growing the reliability and popularity of PSTN network. So, next is the ISTN network, is the telephone system, that is way to transmit the voice with some special services available for the data. So, PSTN is dedicated for the voice earlier, and the ISTN is dedicated for the data as well as voice. So, the main feature of IST is that it can integrate both the speech and the data. So, the smart card contains the international mobile subscriber identity, which allows to send and receive the calls and receives the other subscribed services, and protected by the that is the mobile subscriber integrated service digital network, that is MSIDN. Mobile number is a mobile number which is protected by a password, that is the SIM pin. So, it can be moved up to phone and contains the key information, So, what is the base station system does? The base station subsystem is a link between the MS and the GSM. So, which is a certain interfaces. Under that is application binary interface is an important interface. between the two binary program modules. Often one of these module is a library and other is a operating system facility, and the other is a program that is being run by user. So, the interfacing allowing operation between the components made by different supplier. So, next is our base transceiver station and the base station controller. So, base station subsystem which communicate with the mobile station over a air interface using the protocol. So, LAPD is the data link protocol used in the ISDN. BSC and BTS are communicate with the LAPD protocol, that is the link access protocol for D channels. So, encodes, encrypts, this is what important. What is BTS does? It is encodes, encrypts, multiplex, modulates, even the feeds the RF signal to the antenna and communicates with the mobile station and BSC consisting of a transceiver TRX units. It is also called the radio base station RBS, which is RBS is going to be RBS is the interface corresponds to the subscriber MS. So, provides the radio link the MS over the air interface. So, the basic components of BTS are radio receivers units, switching and the distribution units, that is RF combining the distribution and environment control unit. So, next is going to be the mobile switching center, home location register, visitor location register and authentication user. So, the equipment register is also a switching system, may have flexible in register and in interworking location register to provide more system functionalities. So, short service message is a wireless switching system. We need to have an SMS gateway, MSSC, that is known as a SMS GMSSC and SMS interworking. These implementation of GPRS for high speed data transmission and reception requires use these additional switching elements, so that is the SGN and CGN. So, SGN stands for servicing GPRS support and gateway GPRS support for GCN. So, that is the mobile switching center is going to be heart of the network. So, manages the communication between GSM and other networks, and billing information is going to be administrative system. That is the next is the mobility management is the registration, location updating and inter BSS and inter MSSC called of SS7 protocol. What is SS7 protocol? It is an international telecommunication protocol standard, that is the public switch PSTN exchange the information control signals. So, that is SS7 network is also called the signaling points. So, which has been established in the year of 1982 and the additional latest version is going to be in the year of 1993. Now, still the 5G networks are going to be used the SS7 protocols. So, next one is the home location registers, which is store the information about each subscriber that belongs to it, and the MSC is in permanent and temporary fashion. As soon as the mobile subscriber leaves its current location area, the information in the LHR is updated. So, the database contains IMSI, MSI ISDN, prepaid and postpaid roaming. Next one is a visitor location register, which is give as a temporary database. So, assigns the TMSI, that is a temporary subscriber number, and controls the mobile roaming in its area and database of the particular subscriber. So, this is going to be belong to that is the visitor location register. Let us move to the block diagram. So, you are able to see in the block diagram that is which is going to have, that is the network system is switching system is going to be heart of the communication network. You are able to see that is the flexible numbering register. FNR stands for flexible numbering register, AUC stands for authentication, HLR stands for home location register, ILR stands for intermediate location register, EIR stands for equipment identity register. So, MSSC and VLR, and interworking IWS stands for interworking frequencies, and the GMSSC stands for gateway mobile switching centers. So, you are able to see these are all going to be interlinked to the all these the system are going to be services are going to be interlinked with the MSSC, because MSC is going to held responsible to generate the temporary number, or that is what it has been identified as the flexible number registers, and it is been communicated with the PSTN, PDN, even in the ISTN network held responsible to communicate with the other services, other BTS, other BSSC and all. So that's why it is known as the heart of the network. Hope this video is going to be informative for you. Thank you for watching this video. So we shall meet in the next video. Thank you.